Okay, continuing our journey through the final comprehensive gateway. Again, don't forget that all of these problems are just being pulled randomly from the same database that generated the first 4 gateways. So if you have questions or want more practice on any particular ones of these problems, go back to the original gateways to see more examples or get more copies of these problems. Here's another graphical problem. They're saying determine f of -2. So remember, this number that goes in is the x-coordinate. This is consistent, so the x-coordinate is the number that goes in. The number that comes out is the y-coordinate. So this question is just saying if the x-coordinate is -2, what's the y-coordinate? That's supposed to say coordinate. Oh god, whatever. So if the x-coordinate is -2, that's here. Right, this is the x-axis. So if the x-coordinate is -2, then this is my point, and so my y-coordinate is 4. So the answer is 4. X and y intercepts, this is something that we should be able to do for every any kind of function that we're given. The y-intercept is always the easier one because it's always the one where the x-coordinate is 0, and if the x-coordinate is 0, the y-coordinate, as we just said, is f of 0. So we get the y-coordinate by plugging in 0 into the formula for x. So 8 times 0 plus 5 times 0 plus 11 is just 11. The x-coordinate comes from, the x-intercept comes from places where the y-coordinate is 0. So in order to find that, I've got to set the equation. Remember this, 8x squared, to set the function expression. Remember, the function expression is describing the y-coordinates. So this is my formula for a y-coordinate, and I want that to be 0. So I need to solve this for x. So this is quadratic. It already has 0 on that side. And so I'll try to factor, but I'm not going to get anywhere factoring here because I have 8 times 11. I need 88 as a product with two numbers whose sum is 5. And so that's not going to happen. So I'm going to use my quadratic formula. We have one giant fraction bar here. So I'll have -b, where this is a, b, c. So -b plus or minus square root b squared. B squared is 25, 5 times 5. Minus 4 times 8 times 11. So I don't know offhand what 4 times 8 times 11 is, but it is way bigger than 25. The denominator here would be 2a, 16. But I can already see as soon as I write this square root that this is not going to be possible. So this has no real solutions because I have a square root of a negative number. So if I did find two answers, they would be those two answers comma 0 as a point, just like this form. But in this case, there aren't any numbers, so this is none. And all that means for a quadratic function, remember a quadratic function is a parabola, all that really means is that my parabola is, I guess it's over here, but it means that my parabola opens upward, but is already above the x-axis. So it's perfectly possible for a parabola to have no x-intercepts if it's concave upward and sitting above the x-axis. This is getting more at this function notation. Again, this is the easier version. The x-coordinate is given, and we just need the y-coordinate. So that's just a matter of plugging in -8 for x. Don't forget that when it says x squared, it means whatever the x is squared, so that means -8 times -8, which we would write this way. So make sure you put your parentheses around it before you put it in your calculator so that you don't get a calculator problem with this. So just literally change the x's into -8s, but I put parentheses around the -8s to make sure the calculator reads it correctly. So whatever that number is goes there. The vertex of the parabola, that's just different depending on how the problem is given. This is given in our this general form. So the x-coordinate of the parabola is given by negative b over 2a, where the b and a are same as they are in the quadratic formula, a, b, c. So a here is 1, b is 4, so that's negative 4 over 2 times 1, so negative 2. So that's the x-coordinate. Traditionally we use h for that, but it doesn't really matter. The y-coordinate of the vertex then is f of whatever you just found. It's got to be the y-coordinate of that where the x-coordinate is negative 2. So just like in the previous problem, I'm going to put this in, put negative 2 in for x, being careful to include parentheses so I don't get a calculator problem. So that's 4, that's negative 8, and that's positive 6, so that's positive 2. So my vertex has x-coordinate negative 2, y-coordinate 2. Oops. So here I'm solving equations. We know with exponential and log equations, our goal is to first get the exponential part, the part where the x is stuck. We want to get that by itself on one side. So in this equation, I want to divide both sides by 3. I'll just leave this as a box for now. So wherever the thing is that's got the x stuck is what I'm trying to isolate. So if I divide both sides by 3, I'll have this, then I add 5 to both sides. So this equation is equivalent to saying 4 to the 4x plus 3 equals 16. So now I've isolated my the exponential part. If I recognize that both sides of the equation can be written as a power of the same base, then I can save myself a lot of trouble and I don't need to drag logarithms into it. And that is in fact what happens here, because 16 is just 4 squared. So since 16 is 4 squared, that means that the powers have to be the same. So the 4x plus 3 power on the left needs to be equal to 2. And so that will happen when x is negative 1/4. This equation, again, these are all just randomly thrown in. So this is fraction equal fraction and cross multiply. If you want to think of it that way, you could also just multiply both sides by 7 to clear the fractions. So however you like to do it is fine. 210 divided by 5 is 42. Here's a problem that is quadratic, so I could try factoring this. If it factors, it has to factor like this. Because I need the two numbers to multiply to be 7, so 7 and 1 is really my only option. On this side, I would need two numbers that multiply to be negative 9, so I would either have 3 and negative 3, or the other way around, something in there. But I'm not thinking of anything in particular that works. Or you could have 9 and 1, so we could have a 1 here and 9 here. And that's pretty close to being right, but it still doesn't quite work. We did FOIL on this. We get an inside term of negative 2x, not negative 3x. So I don't think that factoring is going to work, but I always give it a little bit of a try because that certainly gives me easier numbers to work with if it does work. So the only other option is the quadratic formula. So again, I have a, b, c here. So x is negative b, so that's 3 plus or minus square root. B squared, negative 3 times negative 3 is 9. Minus 4 times a, 7 times c, negative 9. And that's all divided by 2a, so 2a is 14. So if you do the arithmetic under the square root sign here, you see that this doesn't give me a negative number. This is fine, it's a positive number. Let me pause this while I figure out what that number is. All right, looks like that is 261 under the under the radical sign there. So we'll have 3, so this is 3 plus or minus the square root of 261 over 14. There's not going to be anything I can factor out of this that's going to cancel with the 14. The 14 is 2 times 7, and the only thing I could possibly factor out here is a 3. But if you are looking to practice the simplification of the square roots, this does simplify a little bit, because you can tell that 9 is going to be a factor of 261. You can tell that, first of all, because the digits add up to 9, but also because in the expression that we got, it was just the sum of two things, both of which have a 9 in them. So that guy's definitely going to be 9 times something. So if you would like to write it that way, I guess that doesn't really help anything for this one, but under the radical, 261 is really 9 times 29. And the reason that that helps is that when we have the square root of a product, that's really just the product of the two square roots. So the square root of 9 can be separated, and the square root of 9 is 3. So this is exactly the same thing, but as you can see, since there's no factor of 3 in the denominator, it doesn't really simplify the problem. But those are the two solutions. The last problem on this page is another one that is exponential, and our strategy is first get the exponential part isolated, and this one's nice enough to already look like that. Our second thing we do is see if both sides can be written as a power of the same base, and in this case we cannot. 18 is not 2 to a power, so that means that I need to just change this into a logarithmic expression. So the logarithmic expression here would be the log base 2. So the inverse of an exponential equation in base 2 is a log equation in base 2. And the inputs and outputs will swap. So the 18 that was by itself is now inside the log, and the 4x plus 1 that was inside the exponent is now outside. So the roles get switched, and so that means that now I can subtract 1 from both sides and then divide both sides by 4, and my final answer will be log base 2 of 18 minus 1 all divided by 4. And I would just leave the answer like that. There's no reason to compute that. In 17, we have our exponent already isolated, and it is written as both sides are exponentials with the same base, and so therefore I know that the bases have to be equal. And the only way that can happen is if x is -1. Here, I have a perfect square equal a perfect square, and so I can say that the square root of the left side, 36w, then is plus or minus 2. So when I'm solving an equation like a squared equals b squared, the solutions are a is plus or minus b. So that's all that's really happening here. So that means that w is plus or minus 2/6, but 2/6 is the same as 1/3. So plus or minus 1/3. Number 19 is just a linear equation. It's got a fraction in it, so if we don't want the fraction, multiply by 5 right away. But remember to multiply the whole thing by 5. So if you multiply the left side by 5, you're going to get 5 times 2x over 5 plus 5 times 16 is equal to 5 times 2x. So the 5 is multiplied by everything. Essentially, you're distributing that multiplication by 5 through the addition on this side. So here, these 5s cancel out, so I have 2x. That was the whole point. That gets rid of the fraction. 5 times 16 is 80, and this side we have 10x. So now it's easy enough to subtract 2x from both sides. 80 is 8x, so x is 10. It's a nice number. It's easy to check. 2 times 10 is 20. 20 over 5 is 4. 4 plus 16 is 20. So that does. In this last problem, we have a logarithmic equation, but the logarithm's already isolated for us, so that's nice. So that means I just need to convert this into an exponential equation. The base here is 9. You can't see that. You should look at the PDF that's posted. It's a little clearer. But the base here is 9. So that means that this will be equivalent to an exponential equation with the same base. So log base 9 will be equivalent to an exponential base 9 equation. But these inputs and outputs get swapped. So instead of the 8x plus 6 being tied up inside of the log, the 8x plus 6 will be free out here. And instead of the 3 being free over here, the 3 will be tied up in the exponent. So in the exponential equation, the x now is free. Now we'll need to know what 9 cubed is. That's 729. And so solving this is just a matter of subtracting 6 from both sides and then dividing both sides by 8. So the value of x will be 723 divided by 8.